Hey guys, so here are the notes for 1.7 day 2. So starting this time, we are now going to be dealing with absolute value inequalities. So today we're going to be solving absolute value inequalities and then displaying our solution on a number line. Afterwards, we're going to write the solution of an absolute value inequality in interval notation. So you're really doing 3 things today for each of these problems. Okay, let's talk about absolute value inequalities, because we are going to do some shading here. Yeah. Okay, so the first thing is we have our less than inequalities. Okay, so you can have the less than or equal to or the less than. Okay, basically we call this an and problem. Okay, what happens is that we can usually shade between 2 numbers. What does that look like? Well, let's say we have a number line. We have 2 numbers. Okay, so like -4 and 4. Basically, we will shade, I'll just make a different color. There we go. We will shade in between those 2 numbers. Okay. So the next one is what we call the greater than. So we can have greater than or equal to or greater than, and this is our or problem. What happens here is that we usually shade in opposite directions. So using that same number line, we have -4 and +4. That means I shade opposite direction. So now in between the opposite. Now you might be wondering, well, how am I supposed to remember this? Well, here we go. So I like to put a D on that than. So less than, so it's like and then for greater, instead of putting maybe ER, I say greater with an OR, greater. So that's going to be an OR problem. So this might really help to know, okay, is this an and or an OR problem? So less than and that's going to be an and problem, so we shade in between. And greater, that's going to be an OR problem, we shade opposite directions. Okay? So let's go ahead, we're going to solve. Now, actually, before we do that, I do want to talk about interval notation, because the idea is that we are going to be using parentheses and brackets and all that stuff, so I will have to add a page for this here, okay? So for interval notation, and we'll explain more of this while we're doing the problems. Okay, so interval notation. Okay, so we will be using brackets. The time we use brackets is when we have equal bars. Okay? There we go. Now we will use parentheses when we don't have equal bars, or we are using the infinity, so like negative infinity and positive infinity signs. Okay? Okay, now another thing I want to talk about, because we're going to see this when we are doing our number line, is the open and closed circles. So if we have an equal bar, okay, that means we have brackets, and that also means we are going to have a closed circle. There you go. Now, if we don't have an equal bar on our inequalities, we're going to use parentheses when we do interval notation, and we're going to have an open circle on the number line. Okay? So I would definitely make sure, like, if you need to, pause this video, write this in your notes because it's not in there. Trying to look, yeah, I don't think it's really in there. So make sure you do pause the video, write this stuff down, because it's really good just so you can refer back to it when you do your homework. Okay, let's go ahead, let's get into a problem here. Here we go. Let's do number 1. Okay, how do we solve absolute value inequalities? Well, it's a little bit similar to how we did absolute value equations. The first step is to create, in this case, 2 inequalities. So our first inequality, we're going to get rid of the absolute value bars, just like we did with the equation. I'm going to keep my inequality sign, and the number that's on the other side of the inequality stays positive, okay? Now I'm going to create a second inequality. So I keep that same variable. Now on the second inequality, you flip the inequality sign. So I'm going to flip it. And I'm going to negate the number. So there now are two things you have to do for the second inequality. Flip the sign and negate the number. Okay, once we have created our two inequalities, this is where we want to figure out, is this an and or an or problem? In order to figure that out, we have to look at the original inequality. Well, we look here, this is a less than. So that means it's an and problem. Okay, so this is where also you might have to kind of really, if you have troubles figuring out, well, what is the inequality? Remember, less than. So the small little point is going to the left, and then the other way. So be careful that you know your inequality signs. Okay. Now with and problems. Okay. Well, actually, before we get into that, now the next part is to solve. So meaning that we get a variable and then the inequality to a number. If we look at both our inequalities, are they already solved for? Yes. Okay, so we don't have to do that. That's one less thing we have to do. Now, going back to and problems. Okay, so notice how we wrote this. We have C is less than 5 and C is greater than -5. Now, there is another way that we can write this. It's what we call a compound inequality. Now, this is only for and problems, okay? Get rid of this quote, and I'll just put a little star next to it. Only for and inequality problems. So when we get to the ors, you cannot do this, okay? Only for the ands. So how we're going to write this as a compound inequality is that we're going to have C in the middle. Okay, so I have C. Now the idea is that our C is going to be in between the two numbers, so -5 and +5. Now anytime that we do write something, we like to go from least, so from the smallest to the greatest, okay? So smallest to biggest. So if we look at the two numbers, 5 and -5, which one is the smallest? Well, it's going to be -5. So I'm going to put that on the left-hand side of my C. So which one's the biggest? That's going to be 5. Okay. So with the idea, since C is actually in between -5 and 5, so it's supposed to be our variables in between those two numbers. So -5, since that's smaller, -5 should be less than C. So it should be smaller, right? Now with C, and we can see this with the C is less than 5, we say C is less than 5, okay? So this is how we write a compound inequality. Your variable's in the middle, and then you have your smallest number on the left-hand side, biggest number on the right-hand side. And what it's saying is that our variable is in between two numbers. In this case, -5 and +5. So reading this, we say -5 is less than C, which C is less than 5, okay? So on your homework, you will have to write it as a compound inequality anytime that it is an and problem, okay? So here's our solution so far, just writing it. Now, our next thing is we need to do it on the number line, okay? So I'm going to scroll down a little bit. I'm going to keep that so we know. So our next thing that we need to talk about is putting these numbers. So just like we did it with our compound inequality, we need to, on our number line, go from least to greatest. So we got -5, we can put 0 in the middle, and then 5, okay? Now, the next thing to determine is our circles, okay? So that's why I talked about this. Now we got to deal with circles. So remember, it's a closed circle on the number line when we have equal bars, right, on our inequalities. So closed circle when we have equal bars. It's an open circle when we don't have equal bars, okay? So if we look at our inequality here, or really our compound inequality, if we look, do we have equal bars? Well, we don't. So that means when we do this, we're going to have open circles on our number line, okay? Now you put open circles on those solutions. So at -5 and +5, because that's part of our solution, okay? Now notice that C is in between -5 and +5. What does this really mean? I'm going to go ahead and kind of draw above the number line, and then I'll draw on it, okay? Well, if C is in between, we want numbers that satisfies that compound inequality. Let's talk about -4, okay? So -4, is that in between -5 and 5? Meaning, is -5 less than -4, and -4 is less than 5. Is this a true or false statement? Well, this is a true statement, okay? Because -4 is bigger than -5, but it's smaller than 5. So that works, okay? Then let's try 0. So we have -5 is less than 0, in which it's less than 5. Is this a true statement? Well, yeah, 0 is in between -5 and 5. It's bigger than -5, but smaller than 5, okay? So it's looking like numbers that are, inside here is working. Okay, let's go numbers between 0 and 5, right? You can pick anything. Let's try 3. Okay, so -5, right? So 3, let's see, is 3 in between -5 and 5? Yeah, 3, so -5 is smaller than 3, and 3 is smaller than 5, so that works. Now, why am I doing this? Okay, well, let's go back to the idea when we talked about and or problems. We said and, that with any of these problems, we shade in between. We shade in between the two numbers, right? So we're seeing really the understanding why do we shade in between for and problems. It is because the numbers that are in between our numbers, like in this case, -5 and 5, they give us true statements, okay? So we tried a number in between -5 and 0. We tried 0 itself, and we tried a number between 0 and 5. Those all gave us true statements. So if we get a true statement, we can shade where we get that. Now let's look at a number that is outside, meaning like -6. Let's see if that works. So -5 is less than -6, which is less than 5. Okay. Is -5 less than -6? No. Okay. So this does not work because this part is not true. Okay. So because we get a false statement, we are not going to shade on the left-hand side of -5. Well, let's see, what about anything that is on the right-hand side of 5? So let's try 6. That's always easy. So -5 is less than 6, which is less than 5. Is -5 less than 6? Yes. Okay, so that works. Now 6 less than 5? No. So that part is not true. So that means the statement is false, and we can't shade on the right-hand side. So what I basically did is just kind of explain why for and problems we shade in between the two numbers, because all the numbers in between them give us true statements, okay? So like anything between -5 and +5 will give us true statements. Anything on the left-hand side or right-hand side will give us false statements. So that's why we shade in between. Okay, so the last thing we need to do is write this answer in interval notation, okay? Well, let's start off with the numbers, right? Let's start off with our solutions, because the solutions we got, -5 and 5, they have to be part of it. So notice that You know, this is kind of like a segment, right? We start at -5 and then we go to +5. So I'm going to put -5 and 5. So we go to there, right? So if we think about it, we have a starting point at -5. Now, if we have an open circle, right, what are we going to use around our -5? Let's go back here. Notice when we talked about brackets and parentheses, right? So brackets is only when we have equal bars and we have closed circles. But we use parentheses when we don't have equal bars on our inequalities and it's an open circle. If we look, we have an open circle here. So that means we are going to use parentheses around the -5. Now we go to -5, we keep going, and we stop at +5, right? So that's the end of our segment. It's once again an open circle, so we are going to use parentheses. So this is our interval notation here, okay? Hopefully you can read that. It's called interval notation. There you go. So that's how we're going to solve these problems, okay? So we're going to solve the inequality, we're going to graph our solution on the number line, and then write in interval notation. Okay, we're going to do number 2, and then there is going to be a second part to this video, which goes over the other examples. So let's do number 2 together as well here. Okay. Okay, so we have for number 2, absolute value of u is greater than or equal to 1. Okay, first step that we need to do is create 2 inequalities. The first one, we have u is greater than or equal to 1. Notice I took away the absolute value bars. The other one is going to be u. We flip the inequality, so less than or equal to, and we negate the number, -1, okay? Our next thing is to decide, is this an or an and problem? Let's look at the original inequality. This is a greater than inequality. So, because it's a greater, right? Oops. This is an or problem. Okay? Now, with or problems, we do not use a compound inequality. Remember, that is only for and problems. So basically, this is our final solution here. And if we look, right, do we really need to solve for the variable? No. So this is our final solution for what we solved for. Okay, next step is we need to do the number line. Okay, so we have 1 and -1. Okay, so I'm going to put that on the number line. So remember, with your number line, go smallest to biggest. So I have -1, zeros in between, and +1. Okay. Okay, our next question is for the circles. Do they need to be open or closed? Well, to know that, notice for our inequalities, we got equal bars. So we have equal bars, we got a closed circle. So we're going to go ahead and do that. All right, do it in different colors so you guys can see it. There we go. Okay. Now, if we also go back to when we talked about and or problems and where we shade, we said with or problems, we shade opposite directions, okay? Well, now I want to explain why we shade opposite directions. Okay, so this is kind of like when we tested numbers here, right? We're going to do the same thing. We're going to test our numbers to see what works and what doesn't. Okay, so let's pick a number outside of -1. Let's do -2, okay? So with or, right, we have 2, or -2, sorry. So with the u is less than or equal to 1, is -2 greater than or equal to 1? No, that doesn't work. But is -2 less than or equal to -1? Yes. Now this is where it's going to get interesting. With and problems, your number had to satisfy this entire inequality. It had to satisfy this whole thing. With or problems, basically your number only has to satisfy at least one of the inequalities, okay? Just needs to satisfy one of them. So or satisfies at least one inequality. The and problems it has to satisfy both. Okay, so make sure you get that part. Okay, so that works. Now let's try something in between, right? Let's try 0 and see if that works. So 0 is greater than 1. Okay, is that true? No, I'm going to make it this green so we know. No. Okay, is 0 less than or equal to negative 1? No. So it doesn't even satisfy really anything. Okay, so since negative 2 is less than or equal to negative 1, we can shade towards the left-hand side. It satisfied that. But since 0 did not satisfy either of the inequalities, we can't shade where 0 is at. That doesn't work. Okay, let's try on the other side. Let's try 1, right? Or let's try not 1, but 2. Let's try 2. Is 2 greater than or equal to 1? Yeah. Okay, so it satisfied at least one of those. So we can shade there. Okay. So with the OR problems, only need to satisfy, and I'm going to write this here. You should write this here. Only need to satisfy at least one inequality. Okay. With the AND problems, you have to satisfy both inequalities. Okay. And you'll kind of get better at this when you practice and practice and practice more. Okay. So that's why with OR problems, we shade opposite directions. It's because we only need to satisfy at least one inequality, and on the opposite directions, one of those numbers will do that, okay? Okay, our last thing we need to do is write an interval notation. Now notice, I did squigglies, but these squigglies go on forever, right? So we think about like this first squiggly, and it goes on forever to the left side, and forever and ever and ever. What do we use to indicate forever? Well, those are our infinity signs. Now, if we go towards the left and it's getting more negative, right, and going on forever, what does that represent? It should represent negative infinity. So basically, we have negative infinity. Now, we do have a closed circle here, right? So that means it's a stopping point. So we stop at negative 1, okay? On the other side, we don't have anything in between. We start up again at positive 1. And then we go on forever to the right direction, which gives us positive numbers. So we start up again at 1, and we go on forever in the positive direction. Okay, now let's talk about parentheses brackets. Now remember, anytime we have infinity signs, no matter what, you gotta have parentheses, no matter what. But what about around the numbers? Notice that we have closed circles, right? Well, with closed circles, we use what is called brackets. Okay? Now, notice that we have two parts to this. Anytime that we want to join two parts, we use what is called a union sign. Okay? This is to combine or join two or more things. Okay? So in this case, since we have two parts to our interval notation, we have to use the union sign, which is like a capital U, the union sign to indicate we're putting those together. And then that would be our interval notation for the OR problems. Okay, make sure you either go to the filled in notes or watch part 2 of the 1.7 day 2 notes. We're now going to get more, and this will go a lot faster. I just wanted to explain why we do some of the things. In the second video, basically we'll just kind of go over and make sure we understand how to solve, how to write, or how to put it in the number line, and how to write interval notation. Okay, see you on part 2.